Hi, I'm Mr. V. In today's lesson from the Illustrative Mathematics, Unit 5, Solid Geometry, is about putting all of the solids together. And by the end of the lesson, you should be able to say, I can use the Pythagorean theorem, or I can use my trigonometric ratios to help calculate the volumes of prisms, cylinders, cones, and pyramids. So instead of me giving you exactly what you need, I'm going to give you some things, and you're going to have to use the Pythagorean theorem or the trigonometric ratios to do so. But first, we have a warm-up, and that is the math talk. Can you evaluate the volumes of these solids mentally? I'm going to do this, and if you want to pause the video to try to do this on your own first, and I'm going to show you what I was doing mentally on paper. Here I look at this, and I see I've got a prism, and its volume is going to be 120 units cubed. Now, how did I do this mentally? Because this was what I was doing in my head. I said the volume is equal to the area of the base times the height. And this triangular base, the formula for the area of a triangle is 1/2 times the base of the triangle times the height of the triangle. And not to be confused with the height of the prism. So when I substitute the values, I have 1/2 times 8 times 3 times 10. Half of 8 is 4. 4 times 3 is 12. And 12 times 10 is 120. This is a cone. The volume of a cone is equal to 1/3 the area of the base times the height. Now, when I do this in my head, mentally, I get the answer of 50 pi units cubed for the volume. How did I do this in my head? Well, I'm going to substitute the values. The area is pi r squared. And I'm going to put the h on this side of the equation so that when I substitute values, it makes a little more sense. 1/3 times 6 times pi times 5 squared. Well, 1/3 of 6 is 2. So if I have 2 pi times 25, that's 2/4 is 50 cents, 50 pi. Doing this one mentally, I'm going to say it's going to be 200 pi units cubed. I'm not going to multiply it out in my head, 3.141592683. I'm not going to do that. I'll just say the volume of this is going to be the area of the base times the height. The base is going to be pi r squared times the height. And this is what I'm doing in my head. I'm just saying, what is this squared? That's going to be pi times 5 squared, which is 25 times 8. So I have 8/4. Well, how much is 8/4? That's 200 cents. Okay. And this last one, to do it mentally, let's see, it's going to be 24 units cubed. And how did I do that? What was going on in my head when I did this? Because I'm asking you to do it mentally. I've got 1/3 times the base times the height. That's 1/3 times the length times the width times the height. So I have 1/3 times 3, which is 1, times 4 times 6, which is 24. And there you have it. Now, this next part of the lesson, we're going to look at, let's see here. We have several pieces that we're going to look at, and we're only going to go through half of this lesson today. We'll do the other half at another time, so this video will cover up to page 9. So here we have what is missing. How can we get it? That's the question for each of these. Well, I think we're missing the radius. And why do I know that? Well, the volume of a cone is equal to 1/3 times the area of the base times the height, which is 1/3 times pi r squared times the height. I know the height, it's 7. What I don't know is the radius. How can I use this given information of this triangle to be able to solve for the radius? Well, I'm going to use the Pythagorean theorem. It's a right triangle, so I should be able to use the Pythagorean theorem. A squared plus b squared is equal to c squared. My r squared plus 7 squared is equal to 8 squared. So r squared plus 49 is equal to 64. When I subtract 49 from both sides of the equation, I get r squared is equal to 15. And I could solve for r at this point, but I'm looking for r squared to go into this equation. So I'm just going to use this value of r squared when I plug it in. 1/3 times 15 times pi times my height of 7. 15 divided by 3, or 15 times 1/3, is 5. 5 times 7 is 35 pi. Oh, I forgot to tell you. I wasn't doing this mentally, but this is my answer. Now, let's plug this into the calculator to see what we get. 35 pi, as an approximation, is 110.0 when I do this. Do this over so we can see the calculator. When I do this, it's rounded to the nearest unit. So this will be units cubed. In the next one, we can't use the Pythagorean theorem to find the height. The height is what's missing. Volume of a prism is the area of the base times the height. This is a rectangular base, so it's length times width times height. I know the length. I know the width. What I don't know is the height. And I can't use the Pythagorean theorem because I don't know two of the sides. But I can use my trigonometric ratios. Which of the trigonometric ratios would we use? So, ka or toa, the sine, the cosine, or the tangent. Well, let's mark the drawing. I'll do this in purple. From this angle, you go all the way across. This is going to be the opposite. This is the adjacent. So I would use the tangent to solve this. When I plug in the values, I have the tangent of 65 is equal to the opposite, which is h, not the height. It's the height of the thing. It's not the hypotenuse. It's the height, over 3. Where did I get the 3 from? Right here on the drawing. Now, if I multiply both sides by 3, I get the 3 times the tangent of 65 is 6.4. So my height is going to equal to 6.4. Now I can substitute the values and solve. Excuse me. 7.5 times 4.5 times 6.4. I plug this into the calculator. 7.5 times 4.5 times 6.4. And I get 216 meters cubed for my volume. The last problem from today that we're going to talk about is this one. To find the area of this right triangular base, notice it's a right triangular. This is a prism. Volume is equal to the area of the base times the height. And the base is a triangle, so it's got to be 1/2 times the base of the triangle times the height of the triangle times the height of the prism. Well, I don't know this. I'll call it x. How can we find it? I've got a right triangle. If I were to draw it like this, maybe you can see it easier. Hypotenuse is 73. This is 48. This is x. I can use the Pythagorean theorem. The Pythagorean theorem is the fundamental theorem of geometry. It overarches and underscores everything that we do in geometry. So it's important to recognize it when it appears and to use it when you can. So x squared is equal to 73 squared minus 48 squared. If I want to get x by itself, I need to take the square root of this. So I'll plug that into my calculator. SQRT 73 squared minus 48 squared. And I get 55. So this length of this side over here is 55. Well, that's cool. I've got this side, and I've got the height. I can substitute those into the equation. 1/2 times 55 times 48 times 31. And I'll plug this into my calculator. 1/2 times 55 times 48 times 31. And I get this big number, 40920. This is centimeters cubed because it's a volume. But the length times the width times the height, centimeters, centimeters, centimeters. Good luck and success.